Hi, welcome to the statics tutorials. We have a region that's defined by this curve y is equal to x squared divided by 4, and we're going to look at the shaded area here from y is equal to 0 to 16. Also, x is going to go from 0 to 8. We want to find the centroid of this shaded region, and so we'll draw a differential element in here. You could use a vertical differential element, or you could use a horizontal. This one I've shown a horizontal differential element. We need to figure out a couple things with this one. One is to calculate the differential area. So this one is a rectangle, so the differential area is just going to be the base times the height. So our dA is going to be x times dy. And then we also need to find the centroid of this differential area element. So we have x tilde, y tilde, that's our centroid of this one. And in this case, you can see that the centroid's right in the middle, and so this is going to be at an x location of x over 2 and a y location of just y. Think of your x and your y being defined by the curve. And so when you're here, you're halfway to the x that you'd have if you were on the curve, but you're at the same y value that you have on the curve. So let's look at our x centroid first. So we're going to look at the integral over the area of x tilde times dA divided by the entire area. So just the integral of dA. Substituting in for x tilde, we have x over 2. And then for dA, we have x times dy. And same thing over here for dA, x times dy down here. At this point, we have a single integral, but it's mixed with x's and y's in there. So we want to eliminate either x or y so that we can do the integral. I'm going to go ahead and just eliminate x. So I pulled the 1/2 out here, combine the two x's to give us x squared times dy. Down here, we just still have x times dy. Looking back at our functionality, we can rewrite this as x squared is equal to 4y, and so make that substitution here, and then we can take a square root and say that x is equal to the square root of 4, which is just 2 times the square root of y. So down here we have 2 times the square root of y dy. So we've completely eliminated the x's. Our only variable in the integration is y. So let's run our limits. We're going to start at 0 and go up to 16. So here are our limits of integration from 0 up to 16. Just pulling the constants out in front of the integrals. And then integral of y dy is going to be y squared divided by 2. Integral of y to the 1/2 is going to be y to the 3/2 because we're adding 1 to the power. But then invert what you have here and put it in front, so it would be a 2/3 factor in front of that. And then we'll run the limits of integration between 0 and 16 on both of these. So when we plug that in, it's going to be 16 squared divided by 2 minus 0 squared divided by 2 on the top, times the 2 that sat out in front. And then on the bottom, we have the 2 that sat out in front, the 2/3, and then the 16 to the 3/2 power minus 0 to the 3/2 power. You could certainly simplify this a little bit. I'm just trying to show you all the steps and show you and not eliminate anything so you can clearly see where everything's coming from. Over here, this gives us 128 for this portion in parentheses and 42.67 for this portion in the parentheses, and that gives us an x centroid of 3 millimeters. Over here for our y centroid, it's the same equation, just with the integral of y tilde dA. So again, now when we substitute this in, we have just y times the differential area x times dy. We still need to get rid of either x or y, so I've chosen to get rid of x. And so substituting in here again, we have x is equal to 2 times the square root of y. It's multiplied by another y, so it's going to give us y to the 3/2. There's the 2 that came out of there. And then we can integrate this top side. The bottom, we've already gotten a numerical value for the integration, so we can just go ahead and plug in that numerical value here that we already have. For the top side, when we integrate it, it's y to the 3/2, so we add 1 to that. It's going to be y to the 2/5. sorry, 5 seconds, so I'm sorry, 5/2, and then the 2/5, when we invert that fraction, bring it out, the 2/5 will go in front. And then same thing, you plug in y is equal to 16, and then you plug in y is equal to 0, that zeroes it out for the subtraction part. And then when you're done plugging in the numbers, you'll get a y bar of 9.60 millimeters. Thanks for watching.